Okay, let's take a look at some exponent rules here. Okay, all of these expressions here have some exponents. Okay, this is x to the third power. This is 2 to the x power. And this is a to the b power. Okay, all of these big ones are called the base. Okay, the base is the big one. That has a power. And when we say power, we mean the exponent. Okay, so that 3 right there, that is the exponent. The exponent is the power. Okay, the power can be a number or a letter, and your base could be a letter or a number. Okay, if you can't see the exponent on a number or a variable, then it's automatically 1. Okay, very important to know. So for this example here, we have 2x to the third power. There is a power on the 2, it's just that we don't always write it. So this is actually 2 to the first power times x to the third power. Okay? All right, yesterday we investigated some things, and so if you have something like this, x to the fifth times x to the third, okay, we're going to simplify by writing 1, 2, 3, 4, 5 x's times 3 more x's, and then we noticed that this was x to the power of 1, 2, 3, 4, 5, 6, 7, 8. So we expanded it and then brought it back. Okay, so what was the pattern that we realized? We don't have to expand them, especially if this said 500 and 300. If you have the same base, okay, we're just going to add the exponents. So the pattern is add the exponents. Okay, and what's the rule? If the same base, then add the exponents. Exponents. Okay? All right, look over here. This is not a multiply problem, this is a divide problem. Okay, so if we were to do this the long way, we would have 1, 2, 3, 4, 5. X times x times x times x times x, and then we would divide by x times x times x. Okay, and then we noticed that we could do lots of canceling because x divided by x canceled out. X divided by x canceled out. There are 3 x's that they both have top and bottom, and there's 2 left in the numerator. So that means it's going to be x squared. Okay, you don't have to put over 1, you can, but you have to make sure that your 2 that are left are in the numerator. So what's the pattern here? I don't really want to write them out, especially if this was 500 and this was 300. So the pattern was we take a look at the exponents and we subtract. Subtract the exponents because they're not combining, they are canceling out. Okay, so what's the rule? If you have the same base, okay, we can then subtract the exponents. Does it really matter if I do 5 minus 3 or 3 minus 5? Absolutely. So maybe we should put a little red star here. Okay, so it's the numerator exponent minus the denominator's exponent. Make sure you do it in the right order. The top minus the bottom. Okay, we're going to practice this a little bit and then you're going to do some. Okay, so this first example right here, let's just get a little bigger. Okay, simplify using the rules and then check with the long way. Okay, so the rule would say when you're multiplying, you add the exponents. Okay, so they're both the base x. There's 5 of them and 6 of them, so I'm going to add, and I think the answer is 11. Okay, now doing it the long way would be to say x times x times x times x times x 5 times. You could put a bunch of dots, I guess, if you want. And then we have to write it times x to the 6th. That means that there's 6 x's. 1, 2, 3, 4, 5, 6. And let's see. Can I combine those? X times x times x times x times x would make x to the 11th power. Okay. Once you get the hang of this, adding the numbers is going to be the fastest way to go. And that's what we really want you to end up doing. Okay. Using the rules here, we're not going to add these powers. Okay. When they're divide, we have to subtract. So they're the same base of y. And if I don't see an exponent, I know it's automatically 1. And so I'm going to do 8 minus 1 to get 7. Okay. Now doing it the long way, in the numerator of the fraction, I have y to the 8th. That's 8 y's. 1, 2, 3, 4, 5, 6, 7, 8 y's. And in the denominator, there's just 1 y. So one of the y's would cancel out. And how many y's would I have left on the numerator? 1, 2, 3, 4, 5, 6, 7. So the answer would be y to the 7th, which is what I got using the rules. Okay. Go nice and slow, figure out the rules, and then you'll be really good at this. Okay, number 3. I see a 3 times x to the 4th times x to the 3rd. Okay, so I know that the coefficient, the number out in front, is going to be 3. Can I combine x's with x's if the bases are the same? Yes, they're all x's. And so what do I do to those powers? I'm going to add them and get the 7th power. Now the long way would be to write this out. 3 times x to the 4th. That's 1, 2, 3. That's 4 x's. And then we've got 3 more x's. 1, 2, 3. So let's see. How can I condense this a little easier? I would write 3 as the coefficient. And instead of 1, 2, 3, 4, 5, 6, 7 x's, I could easily write x to the power of 7. Okay, which is the same thing using the rules. Okay, let's take a look at the next one. The rules that we're studying, okay, these are exponent rules. So we have to be very careful that we don't start using our exponent rules with numbers. Okay, for example here, I see 6 divided by 3. So let's just talk numbers for a second. 6 divided by 3 is going to make a 2. And there's y's and y's. Those y's can be combined. And I don't add the powers, I subtract them. 7 minus 4 is 3. Okay, let's double check doing it the long way. 6 is 2 times 3 times y to the 7th. 1, 2, 3, 4, 5, 6, 7. Okay, and what's in the denominator? 3y to the 4th. Okay, do you see why I wrote 6 is 2 times 3? Because we're expanding everything, and now I'm looking for things that cancel. The 3's cancel, and a set of y's, another set, 4 sets of y's cancel. So what do I have left? All of my things that are left are in the numerator. So I've got a 2, and then I've got these 3 y's right there, 2y to the 3rd. Okay, this is looking good. Number 5. Can you combine things? Yes, if they have the same base. So I see x's and I see y's. So we have to be very careful here that we don't just smush everything together because we're in the smushing mood. We're going to combine our x's because they have the same base. And then we'll combine the y's together because they have the same base. So let's take a look at the x's. There's 6 of them and 5 of them. What are we going to do to those exponents? I'm not going to write the exponent of 65. I'm going to add them and say x to the 11th power. How about y? What's the power on y? 7 plus 8 is 15. Let's make sure that this is right. I would start with x to the 6th, and please write down 6 x's. Okay, now please say times 5 more x's. Okay, this is a long one. Now we'll write y to the 7th. Please write 7 y's. 1, 2, 3, 4, 5, 6, 7. Got them? And now 8 y's. 1, 2, 3, 4, 5, 6, 7, 8. Oh, man, this is a long problem. After this, I really want to start using those rules. How many x's are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's x to the 11th. And how many y's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Perfect. That's what I got over here. So what you're doing in your mind is you're imagining 7 x's and 7 y's and 8 more y's, and then you're saying, wouldn't that be a total of 15 y's? And that's exactly what you do when you use the rule. You imagine all of these y's in your mind. Okay, for the last one here, we're going to divide, and I'll just use the rules. So I'm going to do 10 divided by 2. Okay, so that's how you do numbers. 10 divided by 2 just makes a 5. Now we'll do x's. Okay, how many x's are there? 8 on top, 6 on the bottom. So 8 minus 6 would make 2. And then let's do the y's last. 9 minus 5 is the 4th power. Okay, is that right? Let's see. First, let's expand 10. Let's write it as 5 times 2. And then we'll write 8 x's. 1, 2, 3, 4, 5, 6, 7, 8. And 9 y's. Wow, it's a lot of y's. Okay, and then that's going to be over 2 x to the 6. Please draw 6 x's. And 5 y's. 1, 2, 3, 4, 5. And now we look to see how many of them get to cancel out. Okay, how many of them get to cancel out? Let's see. First, I see the 2 is going to cancel. 2 divided by 2 is 1. So 5 times 1 is just a 5. And we have an x and an x and an x. Make sure you carefully find one x to cancel. I see 2 x's are left, so that's x squared. And then we'll cancel a y and a y, y and a y, y with a y, a y, a y, and then how many y's do you have left? Sometimes when you write so many, it starts to get kind of confusing, which is why the rules are definitely going to come in handy. Okay, I can't wait to see you tomorrow in practice.